Hi everyone. So we're going to start building the electronic dies project on breadboard, and the first step is to build the astable circuit. So to build the astable circuit, you're going to need the 555 timer IC, which is this one here. It's the 8-pin IC, and if you look at the text on there, you can see it says NE555 and maybe some other letters or numbers after it. So the first step would be to place this in your breadboard, and if you build this towards the very left hand side of your breadboard, that'll give you enough room for the rest of the circuit that we're going to need to build. So to put the breadboard in, the IC in the breadboard, make sure the pins line up with the holes and press it down firmly so that it clicks home, and that should be fine. So once you've got your IC plugged into the breadboard, we can now connect the power supply connections. So for the 555 IC, pin 1 and pin 8 are the power supply pins. So if you have the IC in this way with the notch on the left, this bottom pin here, bottom left hand side pin, will be pin 1. Now that pin there is the negative power supply connection, and we're going to use this bottom rail here to connect that. Now I'm using breadboard wire that's already cut to length. If yours aren't cut to length, it doesn't matter, they can loop up a little bit. I just made mine so it was quite clear on this circuit here, so that it was easy to trace where the connections are. So connecting that to pin 1. Now remembering on a breadboard, the connections for a breadboard, if I want to connect something onto this pin here on pin 1, it can go in any one of these other remaining 4 holes that are connected that way. These are all going to be connected to pin 1. So the metal tracks underneath connect this way. Likewise for pin 2, which is the next one along, any one of these remaining 4 holes will be connected to that. So for pin 8 will be this one here, because it counts 1, 2, 3, 4, and then goes anti-clockwise 5, 6, 7, 8. So using another piece of breadboard wire for that connection. Just link it up like so. And I've got my power supply connections for this chip connected. Now I'm just going to work through the diagram. So working from the on the left hand side, you'll see the resistors. We've got 2 resistors that are in series with each other, one connecting to the power supply onto pin 7. So I've got my resistors here. I've cut mine short so they don't stand up too high. It makes it a bit easier for you to see how they're connected. You don't have to do that. You can use the full length of the leads. Might be easy for you to do that. So I'm connecting from pin 7, which is this one of these rows here, onto the positive, and then following on from that, you can see that it's connecting from pin 7 to pin 6 with another resistor, and these are the 2 1K resistors that we're using. So pin 7 to pin 6, I've just bridged across like this with a trimmed resistor. And then from that you can see that pin 6 and pin 2 are connected together. I used a piece of breadboard wire that I cut to length earlier to connect it like this. Okay, so you can see here pin 6, which is this pin here, is connected with this breadboard wire around to pin 2, which is the second pin from the left on the bottom there. And then completing that sort of left-hand side part of the diagram, I've got my 10 microfarad capacitor. So the 10 microfarad capacitor looks like this, and these ones, it's important that you get this right. These are polarized, meaning that they have a positive and a negative. The negative side has the stripe on it. So the pin that's connected to that stripe, we're going to connect that side, that pin, or that leg of the capacitor into the 0 volt rail, and the other leg is going to connect onto pin 2, like so. Finally, we have two other connections we need to look for. We've got pin 4. You'll notice that pin 4 is connected to positive. So using a piece of breadboard wire that I cut to length earlier, I'm connecting pin 4 up to positive. And the other connection we've got to use is pin 5 to using a capacitor to 0. So this capacitor here, it's yellow with a little sort of green end on it. This is, and if you look carefully, it says 10N written on there. You probably won't see that on the camera, but so this is a 10 nanofarad capacitor. Now these are not polarized, so it doesn't matter which direction you put it in. One thing to be a bit careful of is when you remove it from the tape that it was stuck to, that if there's any gum or glue or paper on the ends, to just make sure that that's cleaned off properly. And you can just sort of pinch it between your nails and pull on it a little bit, a couple of times, and that will clean it off well enough. If you're really struggling, you can use your side cutters and clip them short. So this needs to connect to pin 5 to 0 volts. So I'm just going to put that in like so, and then using another piece of breadboard wire that I had cut earlier, this is actually a resistor lead that I'd cut short, and I was just reusing that. It's a bit fiddly now because it's short, so I'm going to use the pliers to get that in place. So this is another trick you might like to use if you're having trouble with something being too sort of fiddly and difficult to manipulate with your fingers. Use a pair of pliers. Okay, let's put that one in. Redo that connection. Okay, that one needs to go in the correct hole there. Okay, so we've actually made the astable now. How do we test it? Well, we can connect the power supply up to it. Now just be extra careful here when you connect your battery in your clip. So I put the battery on the clip already. When you connect the battery in the clip, the black lead is your negative. Make sure that goes in this very bottom rail here. So if you build your circuit on breadboard exactly how I've done this, you can use this video, you can pause it, you can see how I've made the connections. If you make it exactly the same as this, then you won't have any trouble. You've got to pay attention to small details sometimes though. So in this case, one of the details is this negative needs to go in this bottom rail here. This is the 0 volt connection. And this is the positive, the red one is our positive, and that goes in the top rail there. If you get those back to front, you'll damage the chip. It'll get really hot and it'll fry the chip. So make sure that you have those connections in properly. How do we see whether it's working or not? So the best way to see if this is working, well, first, before we modify the circuit to do that, we're going to disconnect the power. I think the best way to see if the circuit's working is to use an LED, and you need a dropping resistor for that as well. So I'll just get those out. Remember, any LED needs a resistor in series with it to protect it from too much current. So I'm going to use connect this onto pin 3. So put the resistor one end on pin 3 and the other end just somewhere else on a breadboard that's not connected to anything. And then using my LED, connect that to 0 volts, like so. Okay. Now when I connect this on here, we can see that the LED is lit up. But is it actually really doing what it's supposed to be doing? So we know that an astable is supposed to be a circuit that pulses, it flashes. But in this case, it's actually flashing faster than we can see it. So included in the pack of parts that you should have received will be one of these. It's got 100 microfarads written on the side. Now, yours might look a little bit different than this, but it's the value down there that matters. It says 100 and it looks like a U. That means micro and F for farads. So these are also polarized, so making sure that you line up the negative of the capacitor with our 0 volt rail. We're going to connect that into the 0 volt rail and that onto there, and something's not working. This should be flashing slow enough that we can see it. Okay, so it's usually going to be a loose breadboard wire connection. So let me see if I can find it. Now it's unlikely to be the power supply because we've got light. It might be this connection here or one of these connections there. Okay. One other thing that you can quite often do is replace breadboard wire. Sometimes breadboard wire can be faulty. So I've got this special breadboard wire that's quite good for breadboarding. It's got plugs and things on the end. It's no different really than yours, except it's just a bit easier to use sometimes. It's also more expensive. Right, something's not right somewhere. Wouldn't have thought it'd be that one, but I'll try it anyway. Okay, I've basically rebuilt the entire circuit. So the next step is to measure some voltages and just see what we've got. So set my meter to the 20 volts setting and just going to see if I can see some voltages on things. Now, it doesn't always tell us a lot. We've got a decent power supply voltage, and so I'm just basically checking between the rails here. So you can see that's our battery voltage there, which should be, if I get it to a good connection, 8.6 something volts. That's reasonable battery. So now if I check that on the actual chip itself, so between pin 1 and, oh, now it's working. So I think there's a loose connection for the integrated circuit there. Yeah. That's all it was, a loose connection on the chip pin. Okay, so now you can see that it's flashing. Now it's flashing quite slow. I'll just restore it back to what it was. Okay. Okay, so this is how we had the circuit before, and after troubleshooting, trying a few different things, what we noticed was that the one of the integrated circuit connections was not connected into the breadboard properly, and that was causing the circuit to not work as intended. So even with people with a lot of experience like myself, we still have problems from time to time, and it's just a matter of trying to figure out what the cause of that problem is. And it's usually something simple. So in this case, the one thing I was testing was, the first thing I checked was the breadboard wires. I replaced them one at a time, and to see if the problem went away, and that didn't change anything. So then I got my tools to measure measure some voltages, and incidentally, just in the process of measuring it, I managed to remake the connection or fix the connection temporarily, and I was able to identify what the problem was. So if you have a similar thing, then you can try those steps. The main things that you find will be things like if the LED is not lit up at all, the first thing you should check is that you've got the LED in the correct polarity. So remember, LEDs have a positive and negative, making sure that the negative is connected to this bottom rail, and the positive, which would be the long pin, or the side with a round edge on it, will be connected to the resistor that's then connected to the integrated circuit. Another problem you might find if the LED is not lit up, just check that you've got the right value resistor there. This should be a 470 ohms, so yellow, violet, brown. A common mistake is to have a 470 kilo ohm resistor there, which is yellow, violet, yellow. That will not work. In addition to that, you can use the techniques I just showed you with checking the breadboard wire connections. So sometimes breadboard wire, the connections aren't great and it doesn't work as intended. In order to be able to see this thing working as slowing it down, we're going to use the 100 microfarad capacitor. Just connect between the 0 volts and pin 2, making sure that we put the negative in the 0 volts there. And that will slow it down by a factor of 10. And so what we're seeing is that it's flashing. And so it's flashing, well, reasonably quickly, a few times a second. And if we were to remove that capacitor, we're going to speed that up by a factor of about 10. And so we won't be able to see it flash, but it will still be doing exactly what it needs to be doing, just faster. So once we've got this working, we can leave it as it is for the moment. We're going to build the next part of the circuit in the next video.